Anna, would you like to announce everyone, AJ and whatever? Or
Yes, for sure, with the big pleasure.
yeah, you are the most beautiful one between us.
Merci, merci, Erjan. But you need to try. You need to take care of yourself. So maybe someday you will also become beautiful. Big problem.
Good luck.
Imagine if that becomes beautiful, then Munir is not going to spare him.
That's right. Nice notice. Okay, guys, a few years ago in Germany, first time we met in beautiful Heilsbad, Heilstadt at Marcus and Matthias' place. And for the first time, we met with Ajay and other guys, as for me. And so there was a meeting with Gregory Zimmerman, who made us short story about UHPC concrete and that the services that they are offering. And so after that, several months passed and we were talking with Gregory about this, and he told me that Ajay from India opened his own production of this material with their help. And this is a very good example on how connections between us are helping us to develop ourselves. And so we are here to see the Ajay and his lessons to us already. And so I'm very glad to see you all. And I hope, Ajay, you will share best you can, and the guys will enjoy your lessons.
Thank you.
Thank you, Anna. That was a lovely.
Thanks, Anna.
Thank you.
Guys, please, can you mute yourself, or AJ can do it?
I will mute.
Okay, I mute myself, although I'm the least one who is speaking.
All right. So I have muted everybody, and I will also switch off my video in a bit, and I will share my screen for the presentation. So guys, first of all, thank you, Anna. Vladimir, I can see you. Okay, so first of all, thank you, Anna, for the introduction. I must say that, you know, when I was talking to Gregor, Anna actually, you know, pitched for us, and she made the introduction much easier and better. And that's where our journey with UHPC started. Today, the presentation, what I'm going to make, was actually a presentation that we made more for a architect. What is that?
AJ.
Yeah.
After your speech, may I say something about concrete cooperation before the presentation?
I think you should do it right now.
Right now? I don't want to cut you.
No, that's okay.
Okay, thank you. Okay, guys, as you know, we have canceled our Russia meeting this year. The causes of coronavirus pandemic forced us to do so. After the pandemic process is over, I hope we will create an opportunity to meet again in real life. If we had not a pandemic process today, we would have been together in Petersburg right now, right this second. As a reference to this situation, I wore a Petersburg t-shirt today. Anna, you see it?
Yeah.
With the cancellation of such meetings all over the world, meetings called webinar started to take place. As World Concrete Cooperation, we decided to give such seminars. As you know, Concrete Cooperation has been operating for 3 years. Although it's a new formation for 3 years, we have covered quite a lot in our activities. The webinar, which we will organize today, will be the first to take a step faster in this way. We plan to organize such webinar meetings every month. Today, we will organize our first webinar on UHPC with our Indian member, AJ. This will be our first, and we are beginner in this regard. I hope it doesn't happen, but some glitches may occur, so I'm sorry in advance. I would like to thank all the people of the world from America continent, Europe, Asia, and Australia who attended this meeting. You can submit your questions after AJ's presentations, and I want to thank AJ to be first in these webinars because, you know, Beginnings are more difficult times to do it, but I'm sure that he will achieve. Thank you, Ajay. I give the verse to you.
Thank you, Erjan. Thank you so much. Yeah, in fact, this is a lovely meeting all of you again after Germany, and all thanks to the technology that we are at least able to do what we're doing now. Well, yes, there are a lot of webinars we created, as well as a lot of webinars what I have attended as well, and it's really educative, and this is the right way to move forward. Great. So let me start with the webinar. I was previously telling you that this webinar was predominantly made more for an interior designer or an architect rather than a concrete professional. Honestly, I am not very well, qualified concrete technologist, wherein I can actually, teach you guys more about concrete. But I would surely share my knowledge and experience with you guys, and I will try to make it as interesting as possible. All right, so here we go. Just a second. Great. So this webinar is predominantly about how you really craft things in concrete, and how UHPC can actually be used to make these beautiful stuff. We predominantly start this webinar with a bit of a history. In fact, concrete has predominantly been known more like a construction grade material, and now, of course, it has taken so many different verticals, so many different roles in our environment around us. So I basically want to start with a little bit of history and how the whole thing is shifted from where it was, from just a construction material to something more interesting. So brutalist architecture is something what started in 1950s. I think just before this 1950, there was a big war, and a lot of buildings around the world was actually demolished. So now what happened is the whole world had to be rebuilt in a hurry. So the architects very smartly took up the whole design level. I mean, design to a very different level, where they actually started. Yeah, that's better. So as I was saying, the architects are very smart. The designers are really smart, and they started to expose material, their finishes. So that is like, let us say concrete is exposed, bricks are exposed, wood is exposed. So there is no plastering as much, and there's no painting really. It's predominantly exposed. So this is one of the buildings of the greatest designer, Le Corbusier, in France. And brutalist architecture was there in the period of 1950s to late 1970s. This is another Le Corbusier's work, which is it's a building that is built in India. So as and how the brutalist architecture really kind of came forward, of course, like everything else, the architecture and the design and the level of detail also started changing. Now this is another project from one of the greatest designers called Tadao Ando from Japan. Now here what you see is Tadao Ando really tried to master his way of casting concrete. Exposed concrete, casting exposed concrete is very difficult, and you generally don't have a control over the kind of finish that you really get. But Taravando is one person who actually made sure that he could get a fantastic finish. And this, of course, is not in 50s, but it is far more later. So you can actually see the kind of evolution to the old photo as well as this. Here it's a lot more refined, and that's how the refinement actually began. Now this was possible again only because of one is his interest. The second is the kind of technology that started evolving around concrete. Now, of course, this is the modern architecture in another step of evolution. This is the cultural center designed by Zaha Hadid in Azerbaijan. And here what you see are all these facade panels. All of these are concrete, ultra high performance panels that have been used. I think, guys, is everyone listening? It seems to have no audio. Sophia, I think you'll have to just reset your connection. I think everybody else is able to hear the presentation. Great. All right. So here, the panels that were used in the facade is basically ultra high performance concrete, and predominantly ultra high performance concrete was initially, introduced by a company called Litheoz in France, and their ultra high performance concrete is called as ductile. We could more or less call them like one of the first initiators of bringing this technology together. And even for today, a lot of these benchmark projects across the globe are made using ductile technology. Now, why UHPC is really used in this kind of a project is basically because of its technical abilities, which I would actually speak to you a little more in the presentation forward. So again, this is also about modern architecture. Here, again, concrete is used for facades, but not really cast at site. But all of these, is what are all manufactured in the factory. It's a pre-cast, and then you come and install it as a facade. So all of this is really possible using the new age concrete. Now, a lot of this might or might not use ultra high performance concrete. I'm not saying that ultra high performance concrete is the only and the best way to achieve all of this. But I would say that, with ultra high performance concrete, you have a lot of technical abilities, which again, as I said, I will give you a comparison a little later, which makes the whole product and the endurance of the material far superior to other technologies like GRC, GFRC, and precast and things like that. More examples of how concrete is really catching up as a trend across the globe. It's not just concrete is predominant in one part of the globe, but all across the globe. So all of these projects, what I've actually been trying to show you, is all from Europe and US and India and many different places. So this is a global trend, and guys, we are in the correct era where concrete is actually catching up at the right time. So this is in Dubai. Here, as what Dubai is never away from the latest trend. So you can see how they've used concrete again as a facade or as a sculptural material. This is the Louvre Museum in Abu Dhabi, and all of these, the screens, what you see, are made in ultra high performance concrete. These are executed by ductile. So with ultra high performance concrete, since as what you guys know, the rebars are not used. It's always fiber reinforcement. So that really allows us to make different types of products. I think the best part about this material is it has no limit. It knows no limit. The limit is in our mind. If we can design something good, then most probably it is possible to manufacture it. So not only is it, architectural, but, you have wall panels. Here again, all of us love the exposed concrete look, but, we don't really need to, have too much of trouble actually trying to build a formwork and, cast concrete, but you can actually use real concrete wall panels to install them directly onto, surfaces and get a real concrete feel in a much easier manner today. And that's again technology. So these are all wooden formed concrete panels. So this is one of the projects that we have done in India, Uber's office, corporate office. This is a high-end residence again where we are showing you the wall panels. So all of these are actually examples. So also another good thing that really happened is the material is so beautiful that a lot of very interesting international designers also started taking this material very seriously. So now this is one of the starting chairs that was designed by Omar Arbel, who's a product designer, and he's designed a lot of other products as well. So again, you can really see how beautifully the product is designed. With the kind of amazing strength that this material has, you can make products so unique and valuable. This again is another technology of concrete where this is a fabric concrete. I think this is called concrete canvas. So this is a fabric impregnated with cement that is available. So you can actually make whatever kind of designs that you would want and pour water on it, and it actually hardens to take its shape. So this again is another amazing thing that has happened in concrete. As what you guys know, I'm sure we have a lot of guys in our group where a lot of accessories and very interesting products have been manufactured. So now concrete is really not only construction of facades, but it's a lot many more products. So this is another designer called Dror Kaspi, and you can see the beautiful designs what they have created using concrete. So there is really no limitation to this material whatsoever. Now, this has got an interesting story. The one on the right side is actually designed by Le Corbusier again as one of his Beton lamps. And a Belgian architect in 2016 got inspired by this very beautiful concrete lamp. And he actually designed this inspired concrete lamp for a company called Floss. Floss is an Italian lighting brand, a very good, very well-known brand, and this is what they are. So now again, concrete is just not something that is just customized, or it's something where it's a DIY. But today, concrete is a very serious material world over. International companies, big brands use concrete in their products right now. These are a few accessories designed by our company. And we are selling them across the globe. And we are also happy to say that, we have actually tied up with a Japanese company where we manufacture their concrete accessories. And these are exported all across the world from the Japanese company. And we recently got a testimonial that our rejection rate is below 2%. And this coming from a Japanese, I would really say it's a feather in the cap. So you've seen a lot of concrete now, right? So we call our UHPC as Litheoz. So that's our brand name. What exactly is UHPC? And how is it really different from other concrete technologies? So this is a very simple and very quick comparison to UHPC and what its technical abilities are. So one of it, I would start from the images on the right. So now this is actually a zoomed in microscopic image of the Litheoz, which was actually, the image was provided from the lab, which actually shows you the integrity of how the concrete is very finely packed. Now, these long strands that you're seeing is actually the glass fiber that we use inside the UHPC. If you see the kind of packing that you really have is very close. Now, what happens because of that is that the water absorption is far lesser. So that gives you freeze and thaw resistant. And because of the close packing, the strength increases. Now that increases your compressive as well as flexural strength to a very large extent. Now this is one of the most important feature of UHPC. UHPC is always developed using a particle packing technology. Now this is what particle packing is. So you have larger particles, and then you have smaller particles in between the larger particles, and then you have even more smaller particles. So let me just give you a very quick example. So it's like, I think this is an example what I think Bob gave me really a long time back. It's like, imagine a swimming pool full of basketballs, and now you have a lot of spaces between the basketballs. So you actually fill it up. You have to fill up all these spaces with tennis balls. Now you still have a little smaller spaces between the tennis balls and the basketballs. So now you put TT balls inside that. Now you still have a lot of space. So you put metal ball bearings inside it. So now you get the flow. So what's happening is, we are actually closing every single possible microscopic particle, packing. We are actually kind of making sure that it packs very, very tightly. Now that is what the difference is. On the right-hand side, what you see is, this is a zoom in of 100 UM. This is a zoom in of GRC. Now these, what you see, are actually the glass fibers. But you can see the kind of cracks that are there. And you can also see the kind of gaps. All the dark spots that you see are all the gaps that are actually there. Now, again, as I'm saying, it's not that just, UHPC is the only way to go. GRC or GFRC is also a fantastic material. It's just about what you want to choose and what is your application. Now, based on that, you actually choose a technology. UHPC comes with its own limitations. GRC comes with its own limitations. It's just about us, to choose what really suits us for our products. A few technical specifications of our UHPC is, the compressive strength is about 100 to 120 MPa. The flexural strength without fibers is about 12 to 15 MPa. Now with fibers, it goes up to 20 MPa, the flexural strength. Of course, it takes amazing, textures because of the particle packing, of course, again, So I will actually, after this presentation, I'll show you a few recent images that were taken from our factory, where it actually, shows you very, very intricate texture copied from the mold using the UHPC. Homogeneously colored, just like GRC, GFRC, resistant to absorption, as I told you, again, because of particle packing, the porosity is less, so it's a lot more resistant to absorption. Resistant to climatic changes. When you say resistant to climatic changes, what happens is, generally concrete is like sponge. It has a lot of pores in it. Now, what happens is, when it's raining or, when it's moist, concrete absorbs water and the water settles down in the pores of concrete. Now, when it actually becomes cold, then, the water in the pores actually turn into ice, and ice expands. Now, when it expands, of course, it actually cracks the concrete. And so that is called freezing. Now, thaw is the opposite. When, the temperature raises, the moisture actually becomes, vapor, and the vapor wants to get out of the material. Now, what happens is, when it travels, again, it cracks the concrete. Now, that is called freeze and thaw. Now, that is what doesn't happen in UHPC because of the particle packing. The absorption is less. It doesn't allow it to, go through this, cycle of freeze and thaw. That's why it's, resistant to climatic changes. UV resistance is about pigments. I will cover this just in a little more time. And as what all of you know, it's put these kind of concrete technologies, be it GRC or UHPC, you can make a lot of molds, and you can cast really unlimited products and designs. Yeah, so again, this is a very quick comparison of UHPC and a precast. So precast is more like a regular concrete. Why we use this? Why we have used a SpongeBob over here is because concrete has a lot of pores like sponge, and UHPC is predominantly the same concrete with Red Bull. It gets its superpowers and it's super strong. So these again are very quick numbers that would actually tell you about the comparison between a regular concrete and UHPC. So what exactly is UHPC made out of? These are a few of the raw materials that are used in UHPC. As I said, the main thing in this is basically the particle packing, and this has to be formulated by a concrete technologist or a specialized professional who actually has the knowledge of UHPC. All of this is general knowledge which is available online, and something what I have gained through a lot of reading as well as interacting with my counterparts. So yeah, you have sand and cement, OPC, that is ordinary Portland cement, and quartz sand. Of course, you use quartz powder to actually kind of use as a filler to actually fill in these gaps in between. And then you also use pozzolans like slag and silica fumes and fly ash, all of that to replace the amount of cement. Now, in our UHPC, most of these are used. Along with this, there are a lot of other ingredients which are not mentioned here, which are used to actually finish our mix of UHPC. Different fibers are again used in UHPC. The dosage of fibers and the type of fibers used in UHPC is a little different from the kind of dosage that you generally do with GRC. GRC is a lot more, it takes in a lot more fibers. UHPC doesn't take in as much fibers as GRC. In fact, if you put the kind of fibers that you put in GRC into UHPC, it actually reduces strength. Now this is again because UHPC has its own strength, and it needs fibers for increasing flexural strength, but there is certainly a formula for it. And again, as I said, not all UHPCs are the same. You can design 100 UHPCs, and it all depends on the person who's designing it, and the values and the dosages of every single item depends on the person who's actually doing it. If you really have an application where you have a lot of cantilever, or you need a lot of strength, that's when you use the metal fibers. Sometimes metal fibers really pop out of the surface, but well, that's the flip side of it. But the kind of flexural strength a metal fiber can give, there's no other fiber that can really give you that kind of strength. And one more reason is metal fibers can be dosed even at say 6% or 10% of the dry powder weight. But any other fibers, just like PVA or glass fibers or any other fibers, cannot really be dosed to that level as these metal fibers. As we all know, concrete is just not gray. You could mix a lot of pigments with concrete today, and there are a lot of very beautiful projects done across the globe with colored concrete, and I'm sure all of us use pigments to color. Now, but I would like to add one point, what I've really learned over the period. Now, not all pigments are equal. There are a few pigments where they are far more UV resistant and stable compared to a lot of other commercial pigments. Now, how this is done is because basically the color fastness, these are all synthesized oxide pigments where the color fastness of the pigment is very high. Now, the color fastness is what is actually used to measure UV resistance. If the UV resistance or the color fastness is very good, then it doesn't fade in an outdoor area. Now, almost all of these oxide pigments, generally oxide pigments have a very good color fastness. It'll have a color fastness above say 5 or 6. Now, these synthesized professional pigments actually have a color fastness of 7 and 8, 8 being the highest. If I have to give you another example, your fabric for that matter uses organic pigments. Now, these organic pigments never have a color fastness above 3. I might be wrong on this figure, maybe 4, but not more than 4, 3 or 4. So when you leave your clothes outside in the sun, you obviously see it lose its shade. That's because of the color fastness. Organic pigments never, organic pigments definitely are bound to fade. And inorganic pigments, that is, those are oxide pigments. What we use are the ones which have a much better life in the outdoor area. So moldability, just like GRC, the ultra high performance concrete can be very well poured. The pourability is, it can be self-compacting. It can flow very, very well. It has a fantastic flow. Or of course, it can also be sprayed using your peristaltic pumps and things like that. So Marcus has a question: what is color fastness? Not sure if I write it correct. So basically, color fastness is what is used to measure UV resistance. The higher the color fastness, the better the UV resistance. The synthesized oxide pigments, inorganic pigments, have a color fastness value of 7, 8. 8 is the highest. I hope I cleared your doubt, Marcus. Yeah, so over here, we are just talking about different possibilities. With the kind of strength what we have, with the kind of textures what we have, with the kind of how it really kind of copies textures from the mold. Okay, I think I missed some chat. Let me get back to this. All right, so so with the kind of particle packing it has, UHPC has, as I told you, really micro particles. Now, another interesting fact about silica fume. Silica fume is 100 times smaller in size. I'm talking about the silica fume particle size is 100 times smaller than that of a cement grain. Now, that means it actually, is so small, and it actually it sits so much well onto a mold, and it copies the texture beautifully. Like silica fume, even other pozzolans actually have a very small particle size. When they actually react with cement, they form a CSH, which again, it's a liquid that turns into be solid. And with these kind of very micro particle sizes, you get textures. And not only textures, these textures actually last long. These are a few things. Now, this is what I actually want to show you later, but I will actually show you a better image just after this. I have a chat. Guys, Anna, I'm not able to. I'm sorry, I didn't understand what you're saying. And Munir, which one are you referring to? Silicon molds. Munir, maybe you can unmute yourself and you can speak. I think that would be better. Okay, porous and travertine texture. All right. So, well, now this is a fantastic thing. We have actually tried our level best, and we have done a lot of trials to actually get natural porous and travertine texture. We didn't want to really copy these textures through a mold where your molds are limited. You might have, say, 15, 20, or even 30 molds. That means you'll actually have so many repetitions. What we really wanted is, having very natural textures. So all of these textures, with a lot of alteration and, with a lot of research, what we did of how to achieve these textures, we have actually achieved these in a very natural manner. And these are not silicon molds. So here are a few possibilities, further, in terms of silicon molds. Now this is a floral texture, which has actually been, casted on a leatherite, on an artificial leather. So you can really see how beautifully, it's copied the texture. This is a special form liner that we imported from Germany. I'll actually show you more images of these. This is beautiful. I'll actually show you more images of these a little later. It's not in the presentation, so I will actually show you other images outside. This is, of course, concrete casted on a fabric, and see how beautifully it actually copies the texture. This is gold leafing that is done on concrete. Concrete is raw, it's beautiful, and a little bit of bling adds a lot of value to it. So now you can get gold leaves, metal leaves in different colors like gold, bronze, silver. So you could just leaf them and seal them after leafing them, so it becomes permanent. Now the stencil work is basically where what we do is we actually cut a sticker. We take a sticker, and we put it on a plotter, and we whatever design we want, we plotter cut it. We expose whatever needs to be colored like this, put it on the counter, put it on the surface, and treat the exposed areas, and we remove the stencil. That's how we do this. Now this is a glow-in-the-dark pigment. You have pigments available. Again, this we imported it from Creso, Europe. They initially glow for about 10 hours a day using they charge using ambient light, and then they glow for about 10 hours. Eventually the power reduces to maybe about, say, 5 or 6 hours over the period of years, but it's still beautiful. Now this is a table that we did with real brass infused. We actually the designer gave us the design for the table, and that was we use real brass. We laser cut the brass. We stuck these brass strips onto the mold, and we casted the concrete. Once we removed it, we gave it a very slight grind on top, and we leveled the brass, and that's the kind of effect that you really got. Now this is we got a master made, and then we made a silicone mold out of it, and then we casted concrete. So this is for a whiskey society in UK, a very prestigious society, and we made a logo plate for them. Now this is acrylic infusion. So let us say you have wall panels, or you have furniture, or you have any kind of light fitting that you do. You could actually infuse acrylic. You can actually cut acrylic, laser cut acrylic, and you can infuse it in concrete, and you can backlight it. So these are a few of our standard products. A couple of this is called as a Fuji series. This is designed by a product designer called as SFDW. So when we're talking about wall panels, I think this is something what I think this is what really explains the difference between a lot of different options available to designers for achieving a concrete finish. On the right side, what you really see is concrete paint. It's obviously maybe 1/10 the cost of the kind of concrete panels what we really do. Now what happens is well, I mean, if you really want a concrete look-alike, you can really get it even at 1/10 the cost. But one thing what I would like to tell you is a look-alike is always a look-alike. A real material is always a real material, and it has its own value. So now this image is what it really explains that very well. On the right hand side, what you have is a concrete paint. You can paint any surface using a concrete paint, and it looks beautiful on day one. But then eventually after using it, this is just after about 6 months of using it, you see how the concrete paint gets eroded. And this is actually painted on a sheet, on a calcium silicate and a cement board. So you see the expansion joints, and then the edges, you see how they get exposed. So this is what I tell my designers. You want to see your project beautiful only on day one? Well, you can go in for a concrete paint, you can go in for a putty, you can do a lot of things. But if you want it to last well, if you want to go back to the project even after 5 years and say, this is a project which I did, and this is the kind of finish, then what you really need to do is use a concrete panel like the way what we've used over here. They definitely last far more longer than any of these kind of options. This again, on the right hand side, what you see is exposed concrete. That is, we call it as exposed concrete in India, but I don't know what you really call it, across the globe. This is where the form work is made on site, and then you pour the concrete. Now, this is the kind of thing what I showed you, what Tadawando has done. Well, a lot better work is possible than what I show, what I'm showing you over here. But what happens is it's very difficult to achieve the kind of finish that you really always want to get. It's okay. So this is called fair-faced concrete, exposed concrete. Okay. So in India, we call it exposed concrete, Munir. Yes, you're right. It is also called as fair-faced concrete. Exposed concrete, I think you're talking about exposed aggregates. Okay. In India, we call this as exposed concrete. All right. Smooth form finished concrete. Great. So, well, so this is a skill-based work. This is a skill-based work which is done on site, and at least in India, we don't have, the skill to achieve the right quality and finish every single time. You see the kind of cracks that could happen. You see the kind of chips that would happen when you're demolding the form work. Again, these are cracks that could happen. Now, all of this can actually be, there's a better way of doing things today. As I said, concrete evolves, every technology evolves. So you can also have these kind of wall panels which are done, which are aesthetic. If you want the kind of strength that you really have, these, form finished concretes that they give you, if it's an architectural wall, if it's a structural wall, of course, the best way to go ahead is, obviously the casting walls, with steels and rebars included in it. But if you're really looking at aesthetics, you really don't need to, struggle so hard and not get a good finish. You could always go in for wall panels this way. Fine detailing, using form finished or, fair finished, concrete walls. It's very difficult to take care of every single nook and corner of how things are done when a building is large. So this is an example where, these are wall panels that are used with the kind of edge detailing that you see here. And this is an example of how a form finished, wall is actually turned out. Not only flat panels, a lot of three-dimensional panels, which actually play very well with light, is also possible. Let me just clear this mark that somebody's made. Just a second. So these are again our standard products. Three-dimensional panels. They play very well with highlights and shadows, used beautifully for making highlighter walls, which are, can be used indoor as well as outdoor. So this is a standard basin that we have made. So we first made this design about, say about 6-7 years back for a customized client. So then what we made is, we actually made a mold which can be used only once. And then, eventually we had to break the mold when we were actually demolding the product. So now what we have made is, we've actually made molds where, the size of the basins can vary. It's, like the actual main wash basin is a fixed size, but the counter can actually vary from being very small to really large. So this is one of our standard product.
What is the floor made of, Ajay?
Sorry, Munir?
I'm saying, what is the floor made of?
Floor. Munir, are you asking about the floor?
Correct. I'm asking about the floor.
Well, I don't know what the floor is made out of. Only this is our product. We don't make floors. All our products are factory manufactured, and we don't do any work which is on site.
Okay, thank you, Ajay.
Yeah. So these are more wash basins that are manufactured by us. This has got a very interesting story. So this was a house which is completely fluidic. The whole house had very, very fluidic designs and not a single straight a wall or a piece of furniture. So accordingly, we made this design with the help of the architect, and we made a mold which lasted us only for one cast, and then this is how we made. So this is a mold that is made using fabric forming. So, well, again, this is another comparison which I would like to give you. These are wash basins which are made of UHPC. GRC also, of course, can be used. And this is how, generally a concrete wash basin would look when you use your regular construction grade concrete. So regular construction grade concrete is not bad, but it is specifically formulated for construction. Taking a lot of parameters about construction is what the construction grade concrete is actually being used. So the application of aesthetic is not really the right thing to do when you're talking about these kind of applications. These are furnitures, what we have done. So this furniture over here can actually accommodate close to about 12 people or even more. This is just a 15 mm shell and has no support or framework inside. It's completely hollow. Now that's the kind of strength that we are talking about. Now this also is about a 5 feet long seater, which can seat up to 3 people. So even 500 kgs loading on this is not a problem.
What are the reinforcement of this table, of this bench?
This reinforcement, are you talking about this one?
The second picture, yes, on the top.
Yeah, this is just fibers. We use metal fibers in this.
Okay,
UHPC
thank you.
metal fibers. All of this is glass fibers. Only this is metal fibers. Even this is glass fiber, for that matter. It's only because of this we use metal fibers.
Thank you.
You're welcome. More furniture. So when you talk about concrete, generally in the general world, they say it's very heavy, it's raw, and you can't shift it from one place to the other. So we are actually making a series of furniture where one person can shift the furniture wherever they want. So now these two are our standard products, where these are hollow. This is hollow. There's only 12 mm in terms of thickness. It's hollow, and one person can actually shift it. These furnitures are heavy enough for it to stay where it is, so that it doesn't get displaced just by moving it or by wind or anything of that sort. But so these are heavy enough for it to stay where it has to stay, and these are light enough for it to be moved wherever you want to move it. Thank you, Anna. Thank you very much. A few of our more works. This is a reception table that we did for Infosys. It's a 15 feet long reception table made in one piece. Now this is another interesting product where this is a 4-seater workstation. The thickness of this is 25 mm. It has a 2 feet cantilever and 8 feet in length. It absolutely has no supports in between whatsoever. So this whole thing is completely cantilevered on both the sides. There are computer, monitors on top of it. There are heavy files on it, and there are even people resting on it. This is, of course, at the end of the day, these are workstations. But this has been about a 5-year-old project for us, and it's perfectly fine. Now, this needed not only glass fiber reinforcement, but glass fiber scrims as well, to make sure that we use it as a secondary reinforcement. That's exactly what we've done here. But this is only 25 mm in terms of thickness, or 1 inch in terms of thickness. Okay, I have another chat. Just a second. Okay, so Munir, I'll see that message a little later. So this is the metal, infused table that I was talking to you about, where we infuse the brass. So this is the table what we manufactured. So this is another thing what we used to actually tell the architects what exactly is concrete, what can you expect out of it, and because what happens is concrete is a new material. It's not been there. The aesthetic concrete I'm talking about is not been there for a very long time. So in many countries, at least in our country, not many people know what to expect out of concrete. One of it is the mottling tones and shade variation. This is very natural and very true to concrete. Initially, we had designers and clients who expect us to give us products which has exactly the same shade and tone in every single product. Well, this is what makes concrete synthetic. If it looks, very similar, it looks like a printed tile, like the way that is put over here. In real concrete, you always have shade variations, mottling tones. Every panel what you cast is different, and this is an inherent property of concrete, and that is what makes it beautiful. Without these variations, concrete would look very boring. Pinholes and bug holes. Well, there are obviously ways of actually making it, completely flawless, but I would say a real concrete lover would actually love these kind of pinholes and bug holes and those kind of flaws, if I can call it. That is what makes concrete more beautiful. So I would always say concrete is actually a flawed material. It's never perfect, and that's the beauty of it. Edge detailing. So coming to the tips and tricks of concrete, I think predominantly all of us face this big issue of the durability of an aesthetic product, starting from a wall panel or a wash basin. Now, a wall panel generally has a surface treatment which repels water, and at least that's what we do. Now, a wash basin always has a surface treatment which keeps it resistant to water and stains as much as possible. Now, well, sealer is a very, very big subject if I have to really get into it, but I'm just trying to cover the surface of it. There are two types of surface treatments predominantly. One is a penetrative surface treatment, which gives you good surface hardness, but it doesn't give you very, very good stain resistance. Now, these kind of things are actually used for wall panels or your floors where you don't expect it to be acid resistant. Now, the other type of surface treatment is film forming surface treatment or resinous surface treatments, which are like PU based surface treatments, acrylic based surface treatments. These initially penetrate the pores of the concrete and form films on top, a very strong film on top. Now, these films are the ones which makes the concrete resistant to your stains. If the film is damaged, then obviously the concrete is exposed and you would have staining problem. I would tell you, at least in our country, a lot of people have tried to use any epoxy surface treatments or polyurethanes or acrylics on concrete and try to make it resistant to stains. Well, I think Bob would really agree with me on this. Not every sealer is a concrete sealer when it comes to such kind of aesthetic products. There are sealers in the market which are specifically designed for such applications, which increases the durability of the product. So guys, whenever you're looking at sealers, don't use any polyurethanes or any epoxies, but make sure that you use professional ones. Now, this is an example of one of the guys who had actually used a I think this should be an acrylic sealer or a polyurethane sealer, if I'm not wrong. And it has gone bad. Now, this is how it has been applied, and this is delaminating after a while. Now, these kind of things will never happen if you're using a professional product. And yes, of course, your application should be perfectly fine. Every product generally has its own application data, and you'll have to follow it to the nail. You should make sure that you follow it exactly like the way the company says they have to, so that you never have these kind of problems. Now, this is a test that we did with mustard, chipotle, and ketchup. This is Harpic. I mean, these are all again available in India. This is a toilet cleaner. This is a kitchen cleaner, and this is a liquid soap. Turmeric in oil, lime, wine vinegar. And we did this trial for 3 hours, 6 hours, 12 and 24 hours. And now this has been the result. Even after 24 hours, we don't have any kind of staining. But again, as a company, we always say, make sure that you're 100% taking care of your concrete products, wipe off the stains as early as possible, and never take a chance. Being safe is better than being sorry. But again, this is what the surface treatment, what we use, is capable of. No matter whatever the surface treatment is, these are absolutely a no-no for any kind of a concrete surface. You cannot or you should not use any harsh chemicals which has solvents and acid-based. It will spoil your concrete surface finish. Abrasive scrubbers and let's say Scotch-Brite or these iron wool scrubbers will always make sure that they scratch your surface, and you're not going to make good to the surface, but you're actually damaging the surface. You might be even damaging the sealer which is on top of it, which is going to lead to many problems. So always stay away from scrubbers. Only use a soft sponge and a diluted soap solution to clean your surfaces, concrete surfaces. Now this is one of the surfaces that got damaged for a wash basin that we made. So they were using scrubbers for at least about 2 years. And this is what happens after 2 years. Now, of course, it can be refurbished, as what you guys know. This is the old surface, and this is how we stripped out the surface treatment, and we refurbished the surface, and we reapplied a new coat of sealer, and this is exactly what we get. Yeah, so this brings us to the end of the webinar that I had planned. I think now is a good time to take questions, and not only questions, but it will be more like a interactive session